This is a lecture on Integrated Services Digital Network called as ISDN. The main topics which come under this chapter are motivation, new services, transmission channels, signaling, service characterization, ISDN standards, broadband ISDN, and voice data integration. Integrated Services Digital Network has been perhaps the most important development to emerge in the field of computer communications in the year 1980, and it will probably continue to dominate the developments in the years 1990s onwards. Unlike many other developments, ISDN is a well-planned area of development in the field of telecommunications. An integrated digital network in which the same digital switches and digital paths are used to establish different services, for example, telephony and data. An ISDN is a network in generally evoking from a telephony IDN that provides end-to-end digital connectivity to support a wide range of services, including voice and non-voice services, to which users have access by a limited set of standard multi-purpose user network interfaces. And the public networks are used for a variety of services, such as public switch telephone network called as ISDN, private lines or leased packet switched data networks, and circuit switched data networks. Firstly, the ISDN is an infrastructure to develop a wide variety of services and is not a network designed for any specific service. Secondly, the end-to-end digital connectivity implies that the digitalization process begins right at the user premises. Thirdly, it should be possible to support every service on ISDN. For any such service is either a voice or a non-voice services. Finally, a small set of careful chosen interfaces should enable the support of all possible services. The users of ISDN should not be burdened with too many specialized interfaces, but at the same time an expensive universal interface should be avoided. And the user has a variety of equipment to connect to public networks, such as telephones, private branch exchanges, computer terminals or PCs, and mainframe computers. A variety of physical interfaces and access procedures are required for connections. The telephone networks has evolved into a digital one with digital exchanges and links. The signaling system has become a digital message-oriented common channel signaling system called as CCS, and SS7 is used for ISDN. The term integrated digital network is used to describe these developments. The public switched telephone network is still analog from the subscriber to the local exchange. The need has arisen to extend the digital network out to subscribers and to provide a single standardized interface to all different users of public networks. ISDN fulfills that need. This is a block diagram of ISDN. Mainly there are two blocks. One is customer ISDN interface and second one is ISDN central office. The services which are connected to customer ISDN interface are telephone, data terminal, PBX called as private branch exchange, alarm, and LAN. LAN is local area networking. And coming to second block, ISDN central office, where it is connected to different services such as packet switched network, circuit switched network, databases, and other networks and services. Motivation for ISDN. In practice, there are multiple networks providing the service nationally. The user, however, sees a single network. Three factors are responsible for the developments towards ISDN. Those are sociological or societal needs, economic necessities, and technical developments. For example, a senior executive of a company who often takes important decisions at home late in the evening or while on a holiday could like to give instant effect to these decisions. This may call for access to different computer systems connected in a form of a network, electronic bank facilities, facsimile transmission, and desktop image processing facilities, all in a place where he is at present. New services in ISDN. ISDN will support a variety of services including the existing voice and data services and a host of new services. Single access line for all services, availability to tailor service purchased to suit needs, competition among equipment vendors due to standards, availability of competitive service providers. A short list of some of the important new services are video text, electronic mail, digital facsimile, teletext, database access, electronic fund transfer, image and graphic exchange, document storage and transfer, automatic alarm services such as smoke, fire, police and medical, and finally audio and video conferencing. ISDN architecture. Architecture of ISDN is defined to follow an evolutionary path. It is natural that an approach is taken with regard to ISDN. The wide range of telecommunication equipments and networks that exist today cannot be replaced overnight by ISDN. As a first step, the existing analog telephone networks should be converted to digital networks. These networks should then be operated along with other existing data and signaling networks. Such networks are termed integrated digital networks. Thus, initially, ISDN will function as a collection of new networks to which an integrated access is provided, as illustrated in figure. It is seen from the figure that 4 different types of networks form part of the architecture. An ISDN exchange and a suitable user network interface permit an integrated access to the network facilities. In a long run, as the economic and technology, the infrastructure will be replaced by an integrated infrastructure as shown in the figure. The motivation for moving into an integrated infrastructure is based on factors like operational issues, management complexities, and economics of realization. It is also based on the general belief that the pooling of resources could lead to an efficient utilization of the resources and better performance of the system. It consists of a common physical interface, ISDN central office, to the digital circuit switched backbone and packet switched network, which further connected to network-based processing services. It consists of ISDN subscriber loop, basic channel 2B plus D, primary channel 30B plus D. ISDN standards. Standardization is an essential process in the introduction of any major and complex international service. The capability of providing true international connectivity and interoperability between networks is critically dependent on the availability of standards and the strict rules to them. The importance of standards has been well recognized in the context of ISDN from the very early stages. CCITT has been playing a leading role and acting as a coordinating body by issuing ISDN related recommendations and thereby guiding the introduction of ISDN internationally. Contained in a I-Series recommendations issued by CCITT, now called as ITU-T, 6 main groupings I.100 to I.600 series. It consists of 6 main groups such as I.100 series for general concepts, I.200 series service capabilities, I.300 series network aspects, I.400 series user network interfaces, I.500 series inter-network interfaces, and I.600 series for maintenance principles. ISDN channels or transmission channels. There are 3 types of fundamental channels in ISDN around which the entire information transmission is organized. The digital pipe is made up of channels. These are the first channel, basic information channel, is called as B channel. Its capacity is 64 kbps. The second channel, called as signaling channel or D channel, its capacity is 16 or 64 kbps, and the third channel, called as high speed channel or H channel. The H channel consists of 3 channels. Those are H0 channel, its capacity is 384 kbps, H11 channel 1536 kbps, and H12 channel, its capacity is 1920 kbps. B channel is basically adapted for telephone digital networks with common channel signaling. Digital telephone networks have evoked around A-law and micro-law encoding of speech signals at 64 kilobits per second. ISDN has the same rate for the basic information channel, although the technology has advanced to a stage where quality voice can be transmitted at 32 kilobits per second or even less. Having adapted a 64 kilobits per second rate, ISDN, however, permits low rate signals to be transmitted by using rate adaptation. Alternatively, a number of low rate information channels may be multiplexed and sent on the B channel. B channel has 64 kbps. It is a basic user channel, can carry digital data or PCM encoded voice or a mixture of low rate traffic. Information streams at rates of 8, 16 and 32 kilobits per second are rate adapted by placing the information bits in the first 1, 2 and 4 bits respectively of an octet, that is 8-bit quantity, in the B channel and filling the remaining bits by binary ones. Streams at rates other than 8, 16 or 32 kilobits per second and lower than 32 kilobits per second are rated adapted in two stages. First, they are adapted to one of 8, 16 or 32 kilobits per second rates and then to 64 kilobits per second by using the technique rate adaptation. Rate adaptation in the first stage is done by creating a frame similar to HDLC frame with the entire capacity filled in by the flag bits. The selection of frame size and frame rate are governed by the user information stream rate and the rate to which it is being adapted. Generally, there are 4 kinds of connections available in B channel, such as circuit switched and packet switched, and the protocol of packet switched is X.25, and the third one, frame mode or frame relay, called as LAPF, and the finally semi-permanent or equivalent to a leased line. The D channel or a signaling channel is primarily used for carrying signaling information to control and monitor ISDN services. It acts as a common signaling channel for all services. As an example, call establishment for a voice call using a B channel is entirely handled over the D channel without the involvement of the B channel. Information transfer on the D channels is governed by a layered protocol along the lines of ISO-OSI reference model. Spare capacity of D channel may be used to carry other packet switch data conforming to the layered model. Main applications on the D channel are user-to-user signaling, telemetry signals for energy management, etc., and low-speed video text and computer terminal data. Its capacity is 16 or 64 kilobits per second, carries information signal to control circuit switched calls on B channels, can also be used for packet switch or low speed telemetry. H channel or high speed channel are used for high speed applications like high speed facsimile video, high fidelity audio and high speed data. A user may also use an H channel as a high speed trunk onto which a number of low rate information streams are multiplexed. H11 channels at the 1526 kilobits per second provides international compatibility, whereas H12 at 1920 kilobits per second may be used in countries which are currently operating the 2048 kilobits per second channel. The H channel carry user information at higher bit rates such as 384 kilobits per second or 1536 kilobits per second or 1920 kilobits per second. It can also be used as a high-speed trunk, can also be subdivided as per user's own TDM scheme. It includes high-speed data, fast facsimile video, high-quality audio, etc. ISDN channels and their applications. You can see there are 3 channels: B channel, D channel and H channel. Under B channel, its capacity is 64 kbps and its applications are digital voice, high speed data, that is packet and circuit switch data, and other applications such as fax, slow video, etc. Coming to D channel, it uses 16 or 64 kilo bps and its applications are signaling using SS7, and low speed data, that is packet, terminal or video text, and other applications such as telemetry. Coming to the final channel, H channel, its capacity is 384 or 1536 kbps. Its applications are high speed trunk, very high speed data, and also other applications such as fast fax or video, etc.